Okay, we're going to do a little, we're going to work out a projectile motion problem here. The problem states that a ball rolls off the edge of a 2-meter high table with a horizontal velocity of 3 meters per second. So I drew out a little picture here so you can see that our ball has a horizontal speed or velocity of 3 meters per second, and the height of this table here is 2 meters above the ground. So just knowing this little bit of information, you can actually solve for a lot of different things. We could find out how long it'll take for the ball to fall, how far away from the edge of the table the ball will fall. You could find out how fast it's going just before it hits the ground. But for right now, what we're going to do is we're just going to worry about how long does it take to fall and how far away from the edge of the table does it fall. So we're going to use the equation x equals 1/2 at squared. But instead of x, I'm going to use d, because your textbook uses d for distance above ground. And instead of a, we're going to use g, because g is acceleration due to gravity. So I'm going to rearrange this to solve for t, though, because I don't want distance. I have my height, I have my distance above the ground, I want time. So I'm going to multiply both sides by 2. That gives me 2d. I'm going to divide both sides by g. And then to get t by itself, I need to square root both sides. So now I'm set up and I can plug in my information and find out how long before that ball hits the floor. So I've got 2 times my distance above the ground, 2 meters, divided by gravity, which we're going to round up to 10 meters per second squared just for ease. So if you notice here, my meter in the numerator cancels with my meter in the denominator. Anytime you have a fraction in your denominator, it flips, so the seconds squared is actually in the numerator, but we're square rooting it. So our unit that's left over is seconds, and that's good. That's what we want. So here what I'm left with is the square root of 2 times 2, which is 4, over 10. And so if you check on a calculator, you should get the square root of 4/10 is a little over 0.6 seconds. So it's going to take less than a second for it to hit the ground, which makes sense. If you drop something off the table, it doesn't linger in the air for very long. Let's see how far away from the edge of the table it's going to go. I'm going to clean our page here, and we can use that 3 meters per second and our time to determine our distance. So we can use the equation distance equals velocity times time. So this, in this case, this x is our horizontal distance before we used d for our vertical height above the floor. We know that our ball was rolling 3 meters per second in the horizontal direction, and we know it's going to take 0.632 seconds for it to fall here. Oops. Let me add in a little second there. Okay. Now, if this 3 meters per second is only acting in the horizontal direction, that's why our x is only going to give us the horizontal distance. Notice that your seconds cross-cancel with your seconds, and you are left with 1.89 meters away from the table. So I hope that this helps you with a little projectile motion math, and I'll see you in the next lesson.